Well, I hope you did well in that quiz. If you have not yet taken it and completed it, please do so. I want to get your scores in there and get that part wrapped up so we can move on to bigger and better things. And these are actually going to be some bigger things for sure. I think it might actually be better too. So just to kind of set the stage here, we've been doing a lot of work with quadratic equations that are all written in such a way that we can always solve them somehow. We can factor them, we can maybe use a graph, we can set them, use by square roots. But all the problems have been written in just one special way so that we can do what we want to do. We're kind of at the point now where you're like, well, what if you can't do all this? If you're not that way, that's what I want you to think about. What if you can't solve by factoring or by taking square roots or so on? And so these last two sections we're going to cover for the next week or so will take you into a world that is guaranteed to work. No matter how crazy the problem is, it's going to work. Now, this first process that we're looking at today, it's a little tedious. I mean, it's guaranteed to work, but it can be really, really tricky if we let it get out of hand. So we're going to keep it pretty toned down here, but I want you to understand the process. And then the next lesson that will actually start tomorrow is really going to dive into a tool that 100% guaranteed always works. It's got its challenges to it, but it's guaranteed to work. Okay, so with that in mind, let me clear off my board here, and I trust you are seeing. Yes, you are. All right, so you see on the board, I've got this phrase, complete the square. And I want to throw out a couple of different quadratic expressions to you and have you see what you think. First one. Okay, second one. Now, one of these is a perfect square, meaning I can write it as this squared. And obviously we know we're going to put an x here, and you can look at the signs, it's going to be a plus right there. So I want you to think for a second, which one of those is likely to be written in that form? If you thought this one, then good for you. It's exactly right. And the way you notice that is that, I mean, this is a perfect square too, so it doesn't, not because 16 is perfect square, but it's because 16 is 4 squared and 8 is twice 4, which means if I put a 4 here, I can write this as x plus 4, x plus 4. And then when I start doing my FOIL problems, I get x squared plus, remember, outers is 4x, inners is another 4x, makes 8x plus 16. So what I get from this is a couple of things. First of all, I know that when I see this, that's going to lead to that number right there. That the number in my factor is going to be half of that number. And then, not surprisingly, if I square that number, I get the one on the end. So this is a perfect square. This is great. This is not a perfect square. Now, there's a technique we can use to make that into a perfect square. But before we do that, I want you to look at a problem like this. X squared plus 10x. I'll write another one over here. X squared minus 6x. Okay, so let's separate these and separate these. So my question to you as we begin to ponder these types of problems is, when I look at this one on the left here, it looks like it has the makings of a perfect square, but it's not complete, right? It's missing something right there. So think about what I just said. It looks like it's almost a perfect square, but it's not complete. What do you think we should do? Maybe we should complete the square. Nice, right? So look back at this example on the right-hand side. See where that 8 started right here? And how that turned into a 4 down here? What number do you think will go right? I know this is an x plus right here. What number is going to go right there? I hope you said 5. Because again, the number that goes in the factor is going to be half of that number here in front of the x term. And then up here, it's going to be 25, and that's the part that's missing. So by adding 25, I have now completed a square. I've completed x plus 5 squared. All right, let's go over here. Let's complete this square right now. I want you to ponder that for a second. And there's two things you can do. You can try to think about what's going to go here, or you can try to think about what's going to go here. I'd like to start here, actually. And let's go with an x here. But I want you to see that minus sign. That means I gotta have a minus sign down here. That's how I'm gonna get the minus 6. So what is that number gonna lead to? I hope you said 3. But then remember, this number here is gonna be minus 3 times minus 3. That's gonna be a plus 9. So by adding 9 to that expression, I have completed the square. So a couple of thoughts here. I'm just going to put this on this page separate. First of all, the last number is always positive. And by last number, I mean like this number and that number there. Okay, so last number in a perfect square trinomial. And in your factor, there's only one factor now because we're squaring it. The number is half of b. Remember this, ax squared plus bx plus c. So b is this number right here, the number, so it's the number in front of x. Not x squared, just x. So let me give you this problem. Let's try this real quick, and then we'll get into how we're going to actually use this. X squared plus something plus 9. I would like to complete the square. Actually, I'd like you to complete the square. So what number or what expression needs to go right there? So now we got to think about this a little bit, because it's not like you can just take this number in half. We don't even know what the number is. But we also remember that this is going to be something squared. Like we know it's going to be 3 squared. Now we're going to have an x there. So now the question is, what goes here? Now you'll notice I put a plus right here. If I put a plus there, that means there's a plus there. Okay? So what expression goes here? Remember that this is half of this. So this should be 6x. And that should look familiar to you, I think, that we've looked at x squared plus 6x plus 9 as being a perfect square. Okay, so great, we can complete a square. So what? What good does that do us? Well, I am super glad you asked, because now I've got two problems. I'm going to show you about how you can use this in practice, all right? And this is going to be a bit of a leap. The goal is still basically the same thing, but we're going to take a bit of a leap forward here. So just go along with me and watch this. X squared plus 4x minus 7 equals 0. So this is a quadratic equation. I'll tell you right now, I'll save you the hassle. You cannot factor this. Well, you can't do it easily. Anybody can factor it eventually, but it's not an easy one to factor. And that's not a perfect square. So clearly we have some work to do, but our thought process here is going to be, let's make a complete square. And this right here looks like the start of it. So the first thing I'm going to do is I'm going to get rid of the 7 totally. That means I'm going to add 7 to both sides. Now, if this is weird to you, I get it. It's okay. We're usually adding 7 to both sides to get to a point where we can solve an equation. I'm not doing that here. I'm simply basically getting it out of the way. So I have x squared plus 4x. Then way over here, I have equals 7. Now notice how I wrote that with a big old gap in between. It's probably a clue that something important is going to go in there. So what might that something important be? Well, this is the point right here when I say, well, that has the makings of a square, but it's not complete. I need to complete the square. So I need to ask myself, what is that square going to be that I'm going to complete? I know that's an x. I know that's a plus. And what is that going to be? Say 2? If so, you chose wisely. Right. So now, if that is 2, what number is needed to complete the square? 2 squared is plus 4. Hey! But wait a minute. Whoa, wait a minute. We've done something bad here. We just added 4 to the left side of that equation and left over here all by itself. We can't do that. Remember way back at the start of the year when I had you up here and you were holding up those paper clips? And if I put 4 on one side, we start tilting. That's not going to work. What did I have to do over here? I have to add 4 over there also to tilt this back. So whatever I do on one side, I have to also do on the other side. Okay, really, I don't know how to make this a bigger deal. You got to do this. Gotta do this. Okay, so now look what we have. X plus 2 squared equals 11. Great, now what? Well, what did we do before when I had x squared equals, let's say x squared equals 13. Well, in the last section, we learned how to take the square root of both sides, and x equaled plus or minus that square root, right? That's how we undo squared terms, by taking square roots. So now, what's what I'm going to do? I'm going to undo this whole squared term by taking a square root, and this one too. Okay, when I take the square root of something squared, I get just that something. But here you got to be super careful, guys. Really got to know this. When I take, I don't know the square root of 11. I'm going to leave it as square root of 11, but I have to have plus or minus in my answer. Have to. Well, how do I solve for x now? Are you thinking minus 2, minus 2? Yeah, that's what I'm thinking. But what does that look like? It means x is going to equal minus 2 plus or minus the square root of 11. Now, that's not a very familiar looking form for me. But just to be clear, the square root of 11 is a number. I don't know what number it is. It is about 3.316. See that? 3.3166. But I don't care. I'm not going to worry about decimals here. I'm just going to write, this is basically how I write my answer. But if it makes you feel better, I can do it negative 2 plus the square root of 11 and negative 2 minus the square root of 11. That is a legal set of answers, either what I circled or what I put a box around. Most of the cool kids use this one here, the top version. So if you want to be a cool kid, you want to write it like the cool kids do. But the ones on the bottom, they're cool too. They just are like thinking, I wish I could be really, really cool and just write one sentence. Okay, so step back from that problem. Look at where we started. This is where we started right here. And look at where we ended up. That's a lot of work to, it gets you a couple answers, which is great. It gets you a fairly complicated looking answer, and there's a couple of scary steps in there. And I want to make it clear, we're just going to look at this for one day. This is just one technique. I think the technique I show you tomorrow, you're going to like better, but you're going to see answers like this. So it's not a whole lot different than this. It just feels a little bit, I don't know, a little fancier, a little more impressive. Okay? All right, let me show you one more example. Second example is x squared plus 8x equals -1. Okay? So now I already have that -1 on the other side. If I moved it to the left so that it looked like this, I'm gonna go back and fix this. But if it looked like this, I could do that, but that's not a perfect square. So that doesn't do me a whole lot of good. I'm gonna see if I can go back. I think I can do it. There. So what I'm gonna do instead is focus just on this. I'm gonna recognize that as written, that is an incomplete square. Okay? So guess what we're going to do with an incomplete square? We're going to complete the square. I got to figure out what goes in here that will lead to this. And I hope you see it's x plus 4. Again, x comes from x squared, plus comes from plus, and the 4 comes from the 8. And then, how do we get there? Are you saying it to yourself? 4 squared is 16. Cool. Oh, but right. If I do it to one side, I have to do it to the other side as well, right? So I got x plus 4 squared, excuse me, equals 15. And now is when, once I have something squared, then I can step in with my square root. Now, I think you're starting to see that we don't always get really nice, clean answers here. That's kind of where we're at now. Remember I told you, we've reached a point where the problems are not written really nicely, and we've got to have some more techniques to get us through this. So I take the square root of both sides, I get x plus 4 on the left, but what happens with that square root? Plus or minus the square root of 50. And now I should know to subtract 4. Subtract 4. This is a weird notation, but x is going to equal -4 plus or minus the square root of 15. Remember, that's what the cool kids do. If you want to be still cool, but not write it like them, you can do -4 plus the square root of 15. It's either this or this. So again, there's no way that we could have just factored this. I don't think I could have even factored that. I would have had to go through a whole different process just to try to factor it, and at that point, I'll just do this. So our goal here is to find a problem that is not easily factored, but that is set up nicely to be a complete square. Usually, that means that this number here is an even number, so it's easy to cut in half. Now, it is possible to do these problems where that number 8 is an odd number, and it gets a little bit more difficult. It's also possible to do these problems where there's a number out front. That's Algebra 2 in pre-calculus. So you shouldn't have to worry about that here. We want to keep it really nice and simple. In fact, I'm going to erase this, I don't deal with that. We're going to keep it just with x squareds, try to keep it with just the even numbers on the x's. We're going to complete the square, add something to both sides, take square roots, get plus or minus, and we solve our answer, solve our problem, okay? Think you can do this? Just one night, guys, just one night. So tonight's assignment is going to be number 11, is page 386, 6 through 9, 11, and 20 to 27. And some of these are going to be just like figure out what's missing to complete the square. And some they're going to be like, here's an equation, solve it. And you're going to get answers like those ones we just saw with like a number plus or minus the square root. So work on that, get familiar with it, but don't stress about it too much, because when all is said and done, we're going to probably end up with a better process than this, and that's coming tomorrow, and you're not going to want to miss it. It's good stuff. See you then.